Hey, what's going on, everybody? I am continuing the series on programming Tetris. Um, this is part 3. I wanted to show you guys that where is it? Oh, yeah. I have the GitHub right here if you guys want to either check out the Tetris GitHub or any of my other random stuff that I've made. That's linked in the description. I wish you want to give that a shout out. So now that we have a good majority of the kind of background setup and everything, I think it's time to start considering blocks. I believe I'm just going to use this set and probably refer to them as those letters because that makes sense to me. So in order to do this, let's start creating some block classes. So here I've drawn a sort of rudimentary graph, and I'm trying to figure out how exactly I want to implement the different blocks and the placements there are. So obviously we could have, so when I'm spawning it, I want it to come in from the top and I want to be able to know all these blocks location given one location. So I think for each type of block that there are, just a reminder, here are the ones that we're looking at. So I think how I want to implement this is determining a certain block out of each block, which is confusing, but these are blocks and they're comprised of smaller blocks. So of those smaller blocks, making one be a quote-unquote parent block, or sub-block, however you want to refer to it, and then the positions of all the other blocks will be relative to that parent, such that I can spawn the parent precisely at the top and know where all the other blocks are relative to it based on that parent block. So given that this is 0, 0 in the top left, this is width, this is height, and let's suppose our parent is at xy, this will be x plus 1, y. This will be y plus 1, comma, x, comma, y plus 1. This will be x plus 1, y plus 1. Can't quite see it, but that's how I'm going to do it based on this parent block. So to create this block class, I'm going to have this be a parent class and create children from it for each block. So class block, what do we need? We'll probably need a std vector of std tuples in int, and we'll just call that block underscore positions. Now we, of course, will need to include vector, and the include for tuples, I think it's actually just tuple. No, we'll do a pair actually, pair. And that include is in utility. And that can be private. We'll have a public constructor. This was a public deconstructor, but I don't think we'll really need that. And so now over here we'll just include block.h and just give some empty constructor and deconstructor. And in our constructor we'll just add to the initializer list block positions being empty. So now I'm going to create block classes for each of the blocks. So there will be, what was that, 3, 4, 5, 6, 7 different classes. Okay, so I've just created empty CPP and header files for each of the different types of blocks. This is kind of, doesn't look that nice, but at least readability's sake, no one will get confused what's going on here. So let's start implementing the basic, hierarchy of it all. So I've just gone ahead and given all the children their class definitions, nothing too much yet. And I wanted to note that I just thought this needs to be protected since the children we want to make sure the children have access to this. So I think one final thing we will need for blocks is probably a block factory. And so if you're not familiar with the factory design pattern, I'll link a quick Google search about it down below. So let's start defining the block factory class. So one thing we'll need to make sure we do here is include the block header. And so we're just going to return, say, a block pointer. This probably can be static. Static block pointer get block given a certain, say, block type. And this can be public. So we don't have block type defined yet since I just made that up on the spot. So let's go ahead and do enum block type. So here's the different types that we could have, and given those different types, we will return whatever type that is being asked. So here we can define the and include block factory. So given the type, let's just switch on whatever type it is. Okay. So in the case we're given an L, let's just return, and in here actually we're going to have to include all the blocks. Cool. So in the case that we have an L, let's just return a new L block. Of course now we have to define those constructors. It's a lot of setup here. So I'm just going to do this for everything and cut there. Okay, that was remarkably tedious. This implementation, albeit very readable, very repetitive. One thing to note is that for block, we want to change the constructor and deconstructor to be protected so that the children can use that parent constructor. So now we can continue with our book factory and just kind of go down the line. And one thing I realized is that we're returning, so we need to get rid of all these breaks. Apparently not a thing. Let's just do a new block, but that should never be the case. I suppose the easiest and stupidest solution for this is just to make that constructor public. I guess it makes sense for the deconstructor to be public too. Whatever. Rolling with the punches. So now in each of the constructors, we're going to want to give what the block positions are, but we should probably know at the time of construction what the base block is. So I suppose in terms of where to place it, we could probably do the parent will always be placed here. So it's 0, 1, 2, 3, 4, 5, 7, 5, 1. Int parent start row equals, what is it, 5. Int parent start call equals 1. Now, switch these. Such that we'll just assume that anytime we're creating a new block, we're doing it in 0, 1, 2, 3, 4, 5, 1, this block. That'll be the parent. And that can exist in our block class so that we can just inherit it. So now for each block, I'm going to have to go and add the positions for the blocks relative to this parent one. So I think the easiest might be for O blocks. So what we can do, and we're going to have to do std make pair of parent start row, parent start column. We could actually probably throw this in the block constructor. So anytime we make a new block, we should always have whatever that parent is already stored in there. So say for O block now, we're going to need to push back, and again for reference, for say O, if we're saying this is our parent block, then we need to add that block, and that block. So this should be x plus 1. So we'll make this one that one. So again, illustrating this, that if this were our parent and it was at xy, we would have x plus 1 y, y plus 1 x, and then x plus 1 y plus 1. So that's what we have here with row and column. So I think we're going to have a bool at the game controller level of should spawn another block, and we will initialize this to be false. Oh, I'm sorry, should spawn another block to be true. So if we are done processing any events from SDL and we should spawn another block, then let's do, we should probably have actually a current pointer to whatever block we are placing at. So we could have block pointer current block being placed, and then we can initialize this to be, I suppose we could make this a unique pointer. And for sake of it, move that up here after Game Boy pointer. So I totally forgot to forward declare what a block is. And so now we can come over here and do current block being placed equals std unique pointer of type block, and then give it the block factory. So let's see if this compiles. Let's go. In this case, we should spawn another block equals false. So in order to connect the functionality of having that game board and a block, we can go into the block and create a new public function that returns a constant std vector std pair int reference. And we'll call that get block position vector. And we can just inline it and say return block positions. So theoretically what we could do is then extend our game board class to have some function. So what we could do with our game board is now say update current block position for whatever block is currently following, and we'll give that. We'll call it, and that's a reference, we'll call this position vector. It will probably not like that we haven't told it what a pair is. Okay, maybe not. So we can now go into our game board So now given the vector, we want to loop over the vector and just set whatever points it is to the certain cell type. So I think what I'm going to do is probably get rid of the cell type and instead just use the block type. So for this we will have to include block.h so we can get that block type. And instead of having cell types, we'll have block type. Let's see. Let's just try to compile and see what yells at me. So we're going to have to extend the block types to have, say, none, wall, and that way we can still use the same types, but anywhere else that it's mad at me, does not look like it. So now we can just loop over, say for std pair, I don't think we'll need the indexes, int current subblock pair that exists within the position vector. We're going to want to have a inline set cell type at index of constant reference row, constant reference call, and we will just return, not return, we also want a block type, and just say gameboard vector dot at row dot at call equals type. So that way we have a way of just a function to update it, and then just set cell type at index current subblock pair dot first, current subblock pair dot second, and we will actually also need the type for this. And we'll just set the type here. So that's going to have a behavior that it's never going to remove any, but let's just try to get something going. We're also going to need each block to store what kind of block they are. And I'm going to get rid of my, I don't like that. So that way, we're also going to have to update the constructor. It seems as though you can't do it this way, so you have to do block. And then this now has to take in, oh, I can make these const and static, by the way. Just thought of that, but we can make this now part of the initialization list for the parent. I didn't know that about C++'s inheritance. I don't know if that's the case with Java, but I didn't think so. But I digress. So now I'm going to do that for all the other blocks. Okay, so I went through and added the initialization of each block to have a member, and now we can finally gameboardcorner.get dot update current block position, and then current block being placed dot get block type, and then the next parameter will be, let me just make this bigger, the current block type, current block type being placed dot get position vector. Now the last thing we're going to have to make sure we do is catch now the case, where case block type is O. It is yellow according to this, so we'll do whatever the hell the RGB is for yellow. 255, 255, 0. Alright, so let's see what happens. Interesting. Oh, that's what happened. Need to have a break. That was awesome. Okay, sick. So now we have a block. I'm going to call that there because we have a functioning block system that can generate a block and draw one. So, thanks for watching this goofy stuff, and I'll see you in the next one.